intelligent monitoring system of electronic equipment based on wireless sensor abstraction, aiming at the problem of poor stability of the intelligent monitoring system for electronic equipment operation status. An intelligent monitoring system for electronic equipment operation status based on wireless sensor is designed to optimize the system hardware structure, building an online monitoring and analysis platform based on wireless sensors and optimize the system software functions. The paper presents a mathematics model for online monitoring of electronic equipment operation status based on wireless sensors and improves the conventional model. The dimension information table is compressed by encoding and storing in the fact table to reduce the storage overhead. The test results show that the performance of the intelligent monitoring system of electronic equipment running state based on wireless sensors is significantly better than the traditional methods. Keywords: wireless sensor, electronic equipment, monitoring system, running state. Introduction. As a present, the domestic research on the operation status monitoring of electronic equipment is mostly focused on offline mode, while online monitoring is relatively small, and some detection functions are realized through virtual instruments, which are only suitable for local detection and cannot complete remote monitoring. In view of the above problems, it is of practical significance to propose an online monitoring system for the operation status of electronic equipment. Literature carried out research on online non-contact comprehensive temperature monitoring system and that does not affect the safe operation of high voltage switchgear, transformer, and other electrical equipment to effectively ensure the safety of electrical equipment operation. Monitoring based on Army directly scanning technology can not only monitor the electrical equipment globally, but also focus on the bus connection points, cable joints, and other parts, and can also improve the effectiveness of the monitoring system and the reliability of electrical equipment operation. Literature designs a wireless network-based remote monitoring system for the status of electrical equipment. The system collects the status signals of electrical equipment remotely through wireless sensor networks and denoises the signals, then tracks the features from the status signals of electronic equipment and introduce machine learning algorithm to fit the relationship between the features and the status of electrical equipment and establishes a monitoring model for the status of electrical equipment so as to obtain the status results of electrical equipment. Finally, the monitoring results of electrical equipment status are sent to the management personnel through the internet. The remote monitoring system of electrical equipment status is simulated and tested. The results show that the system can carry out high precision remote monitoring of sets of electric equipment, but the corresponding solution cannot be given in time when the system has a bug. The hardware design of system adopts BS architecture as application layer. The cloud computing platform is added to the whole architecture to open cloud services for the monitoring system. Integrate the equipment to be monitored according to the distributed layout and complete the unified management of multiple transactions among them. It is necessary to complete the sharing and exchange of data in real time among the application devices and make equivalent connections between mainframe SQL server motherboards, micro converts distributed intelligent system for efficient monitoring is established, and the internal network layout is divided into three levels. The sensor module is responsible for the connection, the data conversion of information in the monitoring area. The processor module is responsible for controlling the operation of the entire sensor node, storing and processing the data connected by itself and the data sent from other nodes, including data security, communication protocols, featureless operationally pro management, task management architecture. The wireless communication module is responsible for wireless communication with other sensor nodes, exchanging control messages and receiving and transmitting collected data. The Pro Management module provides all Pro required for the operation of a sensor node. The traditional sensor monitoring platform mainly includes the following three parts: data acquisition layer, data storage, and analysis layer, data access layer. The field equipment layer mainly uses the data collector at the basic level to collect the data of the field equipment and needs to upgrade the field electricity meter. The field device layer connects the real-time data through the pro data collector and transmits it to the collector via RS-485 bus. The data transmission layer uses the central to centrally process the received data and transmit it to the server through TCP/IP. The user can log in to the designated management account through the PC to access, manage, and monitor the data of each monitoring point. The management application layer is mainly a human-computer interaction interface, providing users with various application functions. In realizing the monitoring of the operation status of pro electronic equipment, it is necessary to see web-related technologies to complete the work of real-time monitoring of the work of pro electronic equipment. And at the same time, it can provide analysis of the corresponding abnormality through the system. Based on the analysis of the characteristics of the wireless sensor network monitoring system, a wireless sensor network-based monitoring system of the running state of electronic equipment is designed. The system is composed of two parts: a field acquisition unit and a remote control unit. The field acquisition unit includes a reduced function loader, RFD, SQL loader, sink, and a gateway. Among them, receives only connected data without routing, and different receives cannot communication with each other. The SQL loader is responsible for collecting the data sent by RFD and selecting the most suitable route to send the data. The gateway sends the received wireless signal to the remote control unit through the wired network. The system is divided into field layer, platform layer, and presentation layer. The field layer takes the integrated monitoring device of electronic equipment as the core to realize the connection, analysis, display, control, alarm, and other functions of various monitoring information of electronic equipment. In order to prove whether the intelligent monitoring system designed this time can complete the real-time monitoring of the fault on the running state of the distributing electronic equipment, solve the problem that the long-term information in the fault area cannot be converted, and ensure the normal consumption of the non-faulty equipment. The method of comparative experiment is used to carry out verify in order to ensure the authenticity and reliability of the experimental results. The MATLAB software is used to process the experimental data and obtain standardize the data result. It is necessary to inspect the operation stability of the system, and at the same time, it is necessary to analyze the data and the information status obtained in the test process to see if it can meet the test standards, which is used to judge the perfection of the system development. Conclusion: in the paper, an intelligent monitoring system for the running state of electronic equipment based on wireless sensors is designed, considering the disadvantages of traditional systems such as cumbersome connection and large redundancy. It is improved. The experimental results show that the storage overhead of the system in this paper is greatly reduced, which is suitable for larger cluster computing and has a higher optimization performance. Although the system designed in this paper contains visualization modules, the research on human-computer interaction has not been carried out in depth. Next, we will focus on improving the human-computer interaction performance to improve the system designed in this paper.